Hello, good evening. Today I'd like to explain about my AI and cybersecurity final project, which is subverting a machine learning spam filter. Before I get started with this project, I would like to say something. This project was implemented from a project which is subverting a machine learning spam filter. I have used that paper as reference to implement this project. Uh, so this project shows how an adversary can exploit statistical machine learning algorithms. What kind of attacks can be done on a statistical machine learning model, and what are the types of defenses we can use to evade these kind of attacks. So do you know what is a spam filtering system? How machine learning is applied to spam filtering system? How adversary can exploit machine learning? So the adversary can make a spam filter to be useless, or he can also make the user to give up using spam filter. Before I get on this, I'd like to explain basic about Bayesian spam filtering. uh, a Bayesian spam filtering categorizes the emails as spam and ham based on the particular word spam score and ham score based on that particular words ham score and pam score. The each email gets divided into either spam or ham. It calculates the probability of all the words in an email, and there is one threshold to be measured. If a particular threshold get exceeded for the spam email, so then it would be categorized as a spam email. Uh, so so to do this project, I have taken Enron spam dataset. This dataset has 33,716 records. It has both emails labeled which as spam and ham. So there are nearly 16,545 ham emails and 17,171 spam emails. Uh, so there are two features of in this data set. One is email, the subject of the email, and the other one is the label. So how did I do the data pre-processing? So when I look at the data set is very raw. It has it's more confused. It has all the emails and their labels. So I had to work around to get all of them into a pandas data frame, and then I had to store this data frame into pickle object because as you see, there are 33,000 records, which is a very high number of records. So my Google Colab file always getting terminated because it's getting out of RAM. So I have increased my RAM, and once I got my pre-processing done for once, I just converted the given existing data frame into pickle object. So I suggest all of you guys to save your data in a pickle file. So using a GPU is recommended because it would process your data faster. So and then as I have told about my data set, so I had to clean the data set before I get on started. So I removed all the punctuations, URLs, unnecessary ones, the numbers and the new lines. And then I have converted all the strings in those emails to lowercase ones so that I'll have a unique vocabulary data set. And so mostly I have used regular expressions here to do this task. So let's talk about data preparation because as we are doing with the strings here, so we need to prepare them. So I have split that string into individual words wherever I have spaces, and then I made each word shorten it into its stem. So I have removed English stopwords. By the way, the stopwords mean, for example, there are these kind of words. The is they would appear in all emails. What I mean to say is like they were like they were repeated so many times in all the emails. So I don't want them to be like getting I don't want them to influence my model. So I have removed the English stopwords. And then that's all what I had done in my data pre-processing. So and I would like to talk about my machine learning model. So as I have already said, my model is going to be a naive-based machine learning model. So as I had my data set done, I had to vectorize words into all. So I had all these emails, right? So the emails, which literally uh, is in text form. So I cannot send this text into my machine learning model. So I need to convert each word into some number, right? So instead of using any label encoder or something like that, I have used vectorized words, which is in a scikit-learn. So what it does is it would generate a TF IDF matrix for all the words in my vocabulary. So so every word literally means something, and which is correlated with other words in my data set. So that's why I have used scikit-learn's vectorized uh, method. And so I have used here stratify parameter here. If you could see, there is a slight misbalance between the spam and ham email. So that's why I had to use this stratify parameter. I'm gonna evaluate my performance of the model with accuracy score. So a simple naive-based model, what I have implemented has an accuracy of 98%, and that's my confusion matrix F1 score and recall score. So I'd like to talk about the dictionary attack now. So as you have seen, my model is ready. It's all set. It's doing its job. So as a adversary, I want the implemented machine learning model to get subverted. So what I would do is I would just try to manipulate the spam score and ham score of the implemented machine learning naive based model. For that, I would choose a dictionary where it has like lots and lots of emails. They all were spam emails, but somehow they were tricked into look like as ham email. So all these models would get into a model, and they also would get trained. So that's how the dynamics of the model gets changed now. For example, so there are a lot of words which happens to be having an high score of spam rather than having the score of a ham. So my model became subverter now. So it would classify more ham emails as spam now because of this dictionary attack. This kind of attacks make user to disable spam filter so that he wouldn't lose any ham emails. So the next attack, what I have implemented is focused attack. So I have to do and focused attack, the adversary needs to know what kind of email he doesn't want you to see. For example, here I have taken a sample email which is related to fruits and flowers. there's this lab experiment going on, and they were waiting for this results of this experiment. So I somehow kind of figured out as an adversary figured out the keywords in that email. So what I have done is I have injected the data set with spam emails, which were in the shape of this above sample email. I mean the keywords what I was talking about. So all the keywords from the sample email was taken, and many spam emails were created around the sample email. After trying this particular range of ham emails, uh, and the algorithm started classifying them as spam. So that's how this focused attack came into play. So what kind of defenses I have implemented uh, in solving these attacks? One is the rejected on a negative impact defense, and the other one is a dynamic threshold defense. So I have chosen both of these defenses to not to subvert my naive Bayes algorithm. So uh, in the first defense, what I have done is, for example, if any email changes my model score drastically, and then like I would just discard that email because it's of having more multiple negative factors. So I would just discard those kind of emails. And the second defense, what I have implemented is a dynamic threshold defense. So I kind of vary here my spam threshold and my ham thresholds. So I would if I observe the changes in these thresholds drastically, then I would readjust them. That's how I implemented these kind of defenses in my model and the results. So what I have seen is my model is kind of doing much better with reject a negative impact defense rather than the threshold one. But I would use a reject a negative impact defense. But the threshold based defense is not bad either. It's doing a decent job, but reject a negative impact defense is great. So here are the metrics what I have seen of using both these defenses. A 96% accuracy I have observed in RONI and a 92 for the threshold-based defense. The confusion matrix seems to be much better for RONI than for the threshold. The F1 and recall scores were also good with the RONI rather than with the threshold one. And conclusion, so if you're trying to implement a RONI, a defense, that would be good for your ML-based filter. So it helps in preventing subversion, and the training needs to be done meticulously. Yep. So I'd like to show you my data pre-processing. Yep. So this is what my data pre-processing looks like. Yep. And thanks for the opportunity. Have a good day. Bye-bye.